In this unit, we will talk about network topologies. Network topology is the study of the arrangement or mapping of the elements of a network, especially the physical or real and logical or virtual interconnections between nodes. Computer networks may be classified according to the network topology upon which the network is based, such as bus network, star network, ring network, mesh network, star bus network, tree network, and so on. A bus network is a network architecture in which a set of clients are connected via a shared communications line called the bus. Bus networks are the simplest way to connect multiple clients, but often have problems when two clients want to transmit at the same time on the same bus. Thus, systems which use bus network architectures normally have some scheme of collision handling or collision avoidance for communication on the bus, quite often using carrier-sense multiple access or the presence of a bus master which controls access to the shared bus resource. A true bus network is passive. The computers on the bus simply listen for a signal. They are not responsible for moving the signal along. Some of the advantages of bus topology are the following. It is easy to implement and extend. It requires less cable length than a star topology. It is well suited for temporary or small networks not requiring high speeds. It is cheaper than other topologies. Some of the disadvantages of bus topology are the following. It is difficult to administer and troubleshoot. It offers limited cable length and number of stations. If there is a problem with a cable, the entire network goes down. Maintenance costs may be higher in the long run. Performance degrades as additional computers are added or in heavy traffic. Low security, because all computers on the bus can see all data transmissions. Proper termination is required, which means that loop must be in a closed path. Then, if one node fails, the whole network will shut down. If many computers are attached, the amount of data flowing causes the network to slow down. And significant capacitive load, which means that each bus transaction must be able to stretch to most distant link. Star networks are one of the most common computer network topologies. In its simplest form, a star network consists of one central switch, hub, or computer which acts as a conduit to transmit messages. The star topology reduces the chance of network failure by connecting all of the systems to a central node. When applied to a bus-based network, this central hub rebroadcasts all transmissions received from any peripheral node to all peripheral nodes on the network, sometimes including the originating node. All peripheral nodes might thus communicate with all others by transmitting to and receiving from the central node only. The failure of a transmission line linking any peripheral to the central node will result in the isolation of that peripheral node from all others, but the rest of the systems will be unaffected. Strictly speaking, only networks that use switches have a true star topology. If the network uses a hub, the network topology has the physical appearance of a star but is actually a bus. Some of the advantages of a star topology are the following. It has good performance. It is easy to set up and to expand. Any non-centralized failure will have very little effect on the network. It is easy to detect faults, and data packets are sent quickly as they do not have to travel through any unnecessary nodes. A ring network is a network topology where each node is connected to two other nodes so as to create a ring. Ring networks tend to be inefficient when compared to star networks because data must travel through more points before reaching its destination. For example, if a given ring network has 8 computers on it, to get from computer 1 to computer 4, data must travel from computer 1 through computers 2 and 3 and to its destination at computer 4. It could also go from computer 1 through 8, 7, 6 and 5 until reaching 4, but this method is slower because it travels through more computers. Ring networks also carry the disadvantage that if one of the nodes in the network breaks down, then the entire network will break down with it, as it requires a full circle in order to function. Some of the advantages of a ring network are the following. Data is quickly transferred without a bottleneck. The transmission of data is relatively simple as packets travel in one direction only. Adding additional nodes has very little impact on bandwidth. It prevents network collisions because of the media access method or architecture required. It prevents network collisions because of the media access method or architecture required. Some of the disadvantages of a ring topology are the following. Data packets must pass through every computer between the sender and recipient. Therefore, this makes it slower. If any of the nodes fail, then the ring is broken and data cannot be transmitted successfully. It is difficult to troubleshoot the ring. Because all stations are wired together, to add a station you must shut down the network temporarily. Mesh networking is a way to route data, voice, and instructions between nodes. It allows for continuous connections and reconfiguration around broken or blocked paths by hopping from node to node until the destination is reached. A mesh network whose nodes are all connected to each other is a fully connected network. Mesh networks differ from other networks in that the component parts can all connect to each other via multiple hops, and they are generally not mobile. Mobile ad hoc networking, featured in many consumer devices, is a kind of a mesh network. Mesh networks are self-healing, meaning that the networks can still operate even when a node breaks down or a connection goes bad. As a result, a very reliable network is formed. This concept is applicable to wireless networks, wired networks, and software interaction.